Hello, I am Diego. In this video, I am going to explain how to use ASReview for the systematic reviews, for the screening part of the systematic reviews. ASReview is a tool, it's an open source software that applies machine learning and active learning to make systematic reviews more efficient. Because instead of manually screening thousands of articles, this tool helps you prioritize the most relevant study first, and then the less relevant studies. And the other thing that I'm also going to talk about in this video is the safe procedure, because you can use ASReview, but these safe procedures help you because by following this procedure, you can improve the quality of your screening and also add credibility to your review, because this procedure has some evidence and it also provides transparent framework. And finally, at the end of the video, I'm going to briefly explain how you could report this kind of thing, because probably you know that for systematic reviews you follow the PRISMA2020, but when you use these tools, there are also some other recommendations to report. And well, let's start with the safe procedure. Safe stands for S is screen random set, A is for active learning. Then in the third phase, you find more studies using deep learning, and finally you evaluate the quality. So the most important part, the most difficult part, is the second phase, because here you apply the active learning. Here you find most of the studies. But you start with the screen random set. With this, in this part, you train the model. So you first, from a random set of studies, you select at least one, and then the tool learns what study you are interested in, and then you move to the second phase. In the second phase, as I talked, you use a simple model in AI, or a simple model in machine learning with deep learning to do the screening, and ASReview helps you to select first the most important studies, as I was explaining, and then at some point, ASReview begins to show you some studies that are not relevant. So at some point you pass to the third phase, that is to use a deep learning, because here you use a simple model, but in the third phase you use a deep learning model, like to find the studies that maybe in this phase wasn't recognized. And then finally, you evaluate the quality. The other reviewer could evaluate if you have done in a correct way. So here is a more detailed explanation. In the first phase, the dataset is random, so it's like when you do a normal screening without using any tool. And then when you find at least one relevant record, the software automatically passes to the second phase. So well, here are the stopping rules, or the rules to end the phase. So when one record is labeled as relevant or as eligible study, you automatically pass to the second phase, because here this of screen a minimum of, well, it's usually 1% of the total number of papers. And when you find one relevant record, probably you also screen this minimum, so you pass to the second phase. The second phase is the active learning. Here is the majority of your time will be spent here, and you continue to do the screening, but now the dataset is not random. In this part, ASReview will help you a lot, because they begin to show you first the most relevant studies, and then at some point you stop when these 4 criteria are met. So first, all key papers have been marked as relevant. Yes, this is because probably when you do a systematic review, maybe you know that there are some trials or studies that are probably need to be included in the study, probably prior to the search. The other criterion is that at least twice of the estimate of the number of relevant records have been screened, and this is you need to calculate this. It's when you in the first phase, when you find at least one relevant record, you get the fraction of relevant records. This is because let's say that you find your first relevant record at position number 100. Then that means that from 100 studies, you have found one study. So the fraction of relevant records is around 1% in this example. So that means that if I have, let's say, 1,000 studies, then 10 studies is an approximation of how much studies are included or will be included. So maybe 10 studies need to be included in this study with this rough estimation. So this number is basically that. So it's that 1%, but multiplied by 2, like twice of these results. So it's not 1%, it's 2%. So in the example, it's not 10, it's 20. Yes, it's 20. And then the other criterion that you must meet, because you have to meet all of these criteria. The next one is that a minimum of percent. This percentage needs to be defined before the study, and there is not like a specific number, but it's something that is usually 10% in this case, because I have mentioned that here is 1%, and here you can use 10%. At least 10% of the total dataset has been screened. So, probably you notice that here you have at least twice the estimate. So in this case, it's 2%, but here is 10%. But yes, that's because there are other cases when you don't have like 1%. Let's say that you have, 10% of the studies have this. 10% is the fraction of relevant records. So maybe this number now is 20%, and then you have to meet this 30% and not only this 10%. And this criterion is the most important. This is the most important rule because, and this rule you have to set in ASReview. It says that no extra relevant records have been identified in the last, for example, 50 records. And this number depends on the total of your studies. Also depends on the topic. Also depends on the search strategy. But let's say that is 50%. No, sorry, not 50%. Let's say that is 50 records in this case. And these 50 records will be the same for the third phase. Probably will be the same in this phase. So the first three rules are usually met when you met this rule, because when you exclude 50 records in a row, you probably have already met the previous rules. And yes, that's the reason why this is the most important rule. Then you pass to the next phase. The next phase is like just, instead of using a simple model, you change the settings of ASReview and you use a deep learning model. And then you apply this last rule again, probably 50 records again. And then you have finished to do the screening. Because in the last part, it's just like another review or evaluate if you have done a good screening, because they receive all the records that were labeled as irrelevant, like all the records that you labeled as excluded studies, and then he tells you if they are really irrelevant studies. And here the stopping rule is the same stopping rule. Probably is 50. The thing that is different is the prior knowledge, because the prior knowledge is automatic when you use ASReview. It's automatic, but in this part you have to manually set up. And there is also something important, that is you have to, because after performing all of this screening, you have to report what things you have done. So you have to report which kind of models were performed. The simple model uses this classifier and this feature extractor, and the deep learning model, you have to choose specifically these things, because this is like the default, but for the deep learning model, you even have to install an extension of ASReview. If you check in the documentation of the software, you can find that the default model have these features. And then if you want to, when you pass to the vector phase, you apply a deep learning model that have this feature. Now that I have explained the safe procedure, now I'm going to apply the procedure to the tool, to the software. So first, let's install ASReview. You can find in the website. In my case, I am using a Windows laptop. And well, you need to install Python. If it's just the first time that you use Python, there are some things that you need to consider. Okay, so we have the file, and then we just install the program, install Python. Well, now Python has been installed. We can close this, and then if you follow the guidelines of the website, you can read that you need to copy and paste this code, but not in Python. Not in Python. You have to install in the command prompt. If you have this problem, this error is common, so you can solve by doing this environment. You click on edit system, path, edit, and here you have to edit this location, and you have to replace with the location of Python. Oh, sorry, Python. You click on the location. This is not a real location, so again, open file location, and here it is. Here is it in Python.exe, but you need to, because the problem is with the pip file, so you click on scripts, and here is the real location of pip. So you copy the address, the location of this, and then you could paste in here. And now click on OK. Then close the command prompt and open again. And then I think the problem is solved. Copy and paste this. And yes, now the program is installing. ASReview is now being installed. The software has been installed. So now we can run this command. We can use this command to open the program, to run the program. But before that, I also want to install an extension, because I have mentioned that for the third part of the third phase of the procedure, of the part that you use the deep learning model, you have to install an extension. The extension you can find in the documentation part. Then is the ASReview dory, and then yes, you just copy and paste this installation in a similar way, and paste this, and just wait. So now that we have installed the program as well as the extension, now we run the program with the following code, with this code, ASReview lab. Yeah. And the program will be opened. We just have to wait. We just have to wait some minutes. Yes. So now the program is running. It takes some minutes, but finally you have the program here. And well, you first drop a dataset. You can click to select where it's located, but also you can drag. And the dataset needs to be, because when you do static review, you remove the duplicates. So after that, you can remove duplicates with a software, the software that you prefer. After that, you have a database like this, that RIS, or any other format can be admitted. In my case, this is my example. And yes, then we begin to screen. So in the program, you have these options. You first have the dashboard. You have the reviewer, that is the place where you include or exclude the studies. You have the collection, a customize section, that is when you, in this section you can change the model, because this is like the default model, it's a simple model, as I showed in the slides. But you can also change, because we have installed the extension. With extension, we can also select this option, and we can even customize with more options. So, well, the default is LS4, that uses SVM as classifier and TF-IDF as a feature extractor. But okay, so before starting the review, I recommend to first set the threshold. The threshold, as I mentioned, the threshold is the 50 studies that I previously mentioned, and the 50 study that I select as an example, but that number could change depending on the quantity of the total number of studies, or your search strategy, that if it was like more specific or more broad. But in my example, is 50. So let's set the threshold at 50 in this case. I also like to include some tags. So in customize, you can add any tag. Well, here I prefer to left right. Okay. But here in the tags, I like to include one that is for reviews, in a way that when you export the file, you could recognize that the review is like from the tag and not from the entire review. I don't know how to explain this thing, but for example, I'm going to write review as this, and then systematic review in this way, in a similar way, For example, this review, this represents systematic review, and then another label for the highest are like the highest ranked papers and the lowest ranked papers. Yes, create a group with these features, and then we can begin to do the screening. So you can see that this record is presented in a random manner. That's because we are currently in the phase number 1. So let's suppose that this study is not interesting for us, so it's not relevant. This study is not relevant. This study is also not relevant. When you do the first part, probably you don't find relevant studies for a long time, like maybe 50 studies, and the study number 50 is relevant. So probably in the beginning you are clicking not relevant a lot of times. As a recommendation, I recommend to just read the title, because read the title, and if you have any doubt, read the abstract. And here you can also click the DOI if you want to read the entire article. So, and why we have these tags? That's because the first, well, these of highest and lowest are because in the fourth phase, in the prior knowledge of the model is the top 10 highest ranked papers and the 10 lowest ranked studies, and that's because and for easy recognition of these studies, we could just mark. For example, let's say that, for example, imagine that this study is like talking about a very different thing, a very different topic. So we could tag as lowest and not relevant. And then we could continue. And let's say that, for example, this study is like a key study, a very important study. So we can mark as highest and then irrelevant. And these other tags of review and systematic reviews, these tags are because when you do a systematic review, you probably already know that besides doing the screening, this kind of screening to include relevant articles, you also sometimes include the studies that are included in a systematic review that is very similar to our systematic review. So if we found a systematic review, let's say that, imagine that this is a systematic review of a topic that is very similar. So we include this as a relevant study, but not as a normal. We include as for example, as a review, as a systematic review, and we include as relevant. And if, for example, it's a randomized controlled trial that needs to be included in our study, we just click on relevant without including any tag. But remember that if it is a very important study, you also click on highest. And I think that probably the majority of systematic review doesn't include a lot of studies. So maybe every time that you include a study that is not a review, probably you will also tag as a highest. Mm-hmm. Yes. So, well, probably you have noticed that. Probably you notice that I don't have this message of this study is shown in a random way, but now we don't have this message, and that's because the program automatically recognizes the study that we are interested in, and then we automatically move to the second phase. So that's the reason why now we are in the second phase, because you know that the stopping rule of the first phase is to find at least one included study. So that's the reason why now are automatically in the second phase. So now these studies are related to the studies that we have selected. Yes. And then at some point, remember that our threshold is 50. So let's suppose that we are doing the screening. So not relevant. Let's imagine that this study is relevant, not relevant. Oh, this is a review that is relevant. Yes. And at some point, we have selected the majority of relevant studies. And now the program is showing us some studies that are not relevant. So we are clicking not relevant. So maybe there are no more relevant studies. So if we click not relevant like 50 times in a row, because that is our threshold, because, for example, now we are 7, and if we click relevant, it's again on 0. And that's because if you remember the stopping rules of the second phase, the stopping rules are all key papers included, also twice the estimate of the number of relevant records, also a minimum of, let's say, 10%, but also that no extra relevant records have been identified in the last, for example, 50 records, because that is our threshold, 50. So that's the most important rule. So let's say that we have completed these 50 studies that are not relevant. Okay, so now let's suppose that this study is not relevant, and we have reached the threshold, that is 50 studies in a row that are not relevant. So how do you want to proceed? So now we have to proceed to the third phase, to the phase number 3, that is using a deep learning model, not a simple model, now a deep learning model. So click here, continue with deep learning model, and then this is the customize section. Remember that we could change the AI. We are going to customize. The maximum is good. The feature structure, now we are going to include this, and classifier and neural fully connected neural network. This is fine for this configuration is fine for a deep learning model, and the balancer is balanced. Okay, so we could continue with the review. Yes, let's suppose that it is not relevant, not relevant, relevant, not relevant. But in the phase number 3, probably maybe we just find one or maybe 5 new articles, because the majority of articles are found, the main majority of articles are found on the phase number 2. So in this phase, we probably, maybe we don't find anything in this phase. And other important thing is that, let's suppose that we have an error. Let's say that we mark this as relevant, but oh no, that study was not relevant. If that's the case, you can click on collection, full history, and first study is the last study that we have selected. So this study we could change not relevant, unless we could modify if we have some error. And then when you again set the threshold, because well, now we are in the phase 3 and we could again establish a new threshold. In the previous example was 50. So now I think that again 50 will be our threshold. So yes, let's continue, and then let's continue. So now if I click on not relevant, again we have reached our stopping threshold. And how do we want to proceed? In this case, now we are going to move to phase number 4. But phase number 4 needs to be done by the other person, because we have finished the screening, and now the phase 4 is just to evaluate the quality. So the project is basically finished. So finish project and export results, and click here on report, on export, and we want to export. All the data, so relevant, not relevant, as well as not seen. And we also it's good to also export a CSV file that doesn't include the unlabeled studies. So not seen is not included, and now we just export a file with relevant and not relevant studies. Export, and now we have these two CSV files. So let's open them. Now we have these two CSV files, but the most important is this one, relevant plus irrelevant, because the not seen, well, we have to include this file when we report. It's for transparency to allow reproducibility, but it's not important right now. Just click here, the first option, relevant plus irrelevant. And this is important because now we are going to design the dataset for phase number 4, for the evaluate the quality phase, and that phase is very fast, but you have to prepare the data. First, I am going to include the studies. So here you have the include studies, and then because in this column you can see the included studies. They are labeled as with number 1, and not the studies are with number 0. So, well, but in some cases you have a lot of included studies. So let's suppose that we have 20 or maybe more included studies. And remember that we have also, I have modified this example. Let's suppose that there are some studies that are marked as text. Remember that here we have the tags. The tags can be, for example, these tags are do you remember this tag, review? Yes, I write I wrote in this way because I want to differentiate from this review. So yes, we have one column of this tag, this is the tag of systematic review, this is the tag of highest, this is the tag of lowest. So first, let's find the ideal studies, the studies that are most important that have this tag. So I'm going to move those studies to the first position. So here, this study is also important. Well, that's it's better to use this kind of filters, you know. Yes. Yes, we have like this one. In this case, it's a CSV file, so this is ordered. If you close and open again, you discover that yes, it's saved in this way. Like first are the studies that are like high yield studies. So sorry, this number should be 0. Okay. And then we have like, you know, we don't have 10 studies because why we need 10 studies? That's because for the phase 4 of the safe procedure, the dataset is not all the dataset. The dataset is only the records that were labeled as not relevant. So we should. So one person could think like maybe we should delete these included studies. The included studies need to be deleted. So all number 1 needs to be deleted. But this is not the case because it's not totally true because in this phase number 4, the prior knowledge includes the 10 highest and the 10 lowest ranked papers. So the 10 high yield studies need to also be included. So we need to first find the 10 most important studies. We have 6, so we could have these 4, for example. And then the other included studies need to be deleted because we only want this included studies for the prior knowledge, for training the model. So I'm going to filter this, and I want to know if we really have all these studies. Yes, these are the studies that need to be deleted. So sorry, this is not in English. Okay, so now we have like 10 studies, and we also need to find the low yield studies. Like here, well, for some reason I don't have this stuff. But let's imagine that here we have some studies that were backed, some studies that have this tag of lowest or super irrelevant studies. So we could find them. So these are some of the studies that needs to be used in the prior knowledge as the lowest ranked papers. So here we have 6, and let's just add 4 studies. And don't forget to label with this number 1 because CSV file doesn't recognize colors, they only use values. So for that reason, it's important to do that. Okay, so now we have first the 10 studies, the 10 more important studies, relevant studies. And then we have 10 super non-relevant studies. So save this file. Okay. Sorry. No, it's important to have this so highest with number 1 and lowest with number 1. And now save the file. It's a CSV file, so if you open again, you can see that the colors were removed, but these numbers are preserved. I forgot to mention some important thing. One important thing is that, let's say that we only have 5 relevant studies. So what if I only have 5, but I need 10 for the same procedure? So you just need to include this tag of highest to some studies that are not relevant but are almost relevant. So you need 10 studies, and if you don't have 10 relevant studies, you have to search for a single study that maybe could be considered as relevant study, but only for the purposes for this. So this series file need to be checked by the other reviewer. So this file you need to send to the other review because the other review have to evaluate the quality of your screening. So now let's imagine that I am the other reviewer, and let's imagine that I am sorry I'm going to delete this. Okay, let's imagine that I am the other reviewer, I am the other person, and I am going to check the CSV file of the other reviewer. This file needs to be uploaded here. I'm going to drag and then screen. But here we don't want to do a phase 1 and a phase 2 parts of the study. We just have to do the evaluate the quality with the prior knowledge. If you remember, in the phase 4, the prior knowledge is the 10 high yield plus 10 low yield studies. So click on customize and here prior knowledge, because this only search studies. And which studies? Well, this is studies that we have upload. So I'm going to open this, and I'm also going to mark these studies with number 1, like the high yield studies. Oh, sorry, the high yield studies. I'm going to color, and the low yield study I'm going to color. Yes. Okay. So now these studies that are like the high yield studies, you copy and paste the author's name here. And that's because that studies we need to label as relevant. So we have to do this manually because for some reason the program doesn't recognize, I think. But there are only 20 studies, so it's relatively easy. So click on relevant. If there are 2 options, you can like click on title and check if it's the same. For example, I'm not sure it is the same. And then after you complete for the high yield studies, you pass to the low yield studies. For example, this is a study that is from other things, so we have to mark as not relevant. And usually it's the same of this, not relevant. And after you have tagged or you have labeled all of these prior, because these 20 are for prior knowledge. After that, probably you have a message that said you added 20 relevant and 20 not relevant reports. You added 10 and 10, so in total 20 reports that are from the prior knowledge. And you can also see that prior knowledge here in the dashboard. You can see that including priors we have 2, and including priors we have 1 of non-relevant. So you have to have like 10 here and 10 here. It's important to include all of these studies as priors, because in this part you are evaluating if the other reviewer exclude the article that really need to be excluded. Because if there is some relevant study in the dataset, then we can conclude that maybe the screening was not perfect. And if we find, I don't know, maybe 2, 3, or 1 study that is considered relevant but was not relevant for the other researcher, then we can conclude that the screening was okay. But if, for example, we find 10 studies, maybe the screening is not correct. But that number also depends on how much studies are included and different other variables. So after that, don't forget to also include a threshold. In the phase 4, phase 4 also has a threshold. Probably, maybe it's the same, like 50 in this example. And that's it. After some times, you will reach the threshold and you receive the same message, and you can export. And when you export, you don't need to export as a relevant study. Sorry, you need to export. Well, in this part, you are just evaluating the quality, so it's not too important to export the results. But for completeness, if you want, you can export all the things that you have. So that's how to do the review lab. And there is also some very important thing about this. When you report the systematic review, you probably also report the complete dataset. So this dataset is not important for evaluating for the phase 4, but is important for transparency, for like when you write the manuscript, you can include this as a supplementary material, or maybe submit or upload to GitHub or to. Besides the CSV file, it's very important to also here export the project, because this ASReview, this is the ASReview file. Like this file contains the technical information of the model, so it's also important for the reporting, especially for reporting your results. Great. So finally, how to report all of these things. So probably you know the PRISMA2020, but for these kind of tools that uses machine learning and active learning, you have to follow the RDAL checklist. And that's because the PRISMA2020 recommends to report these things, but they only recommend to provide like the version of the software and maybe some rules. But the RDAL checklist was developed because for reproducibility, it's better to provide more information, more details. So they create 15 items. The item number 1 to number 7 can be reported in the text, like in the protocol or in the manuscript. But these 7 are important because they recommend to report the item 1 to 7 before, like in advance, before the systematic review, before starting the search procedure. And these other things, item number 8 to number 15, are basically the CSV file and the technical data file that in this case is point or that ASReview. As you notice, the CSV file is this file, but it's not the relevant plus non-relevant. This file includes all the data, like because you have to include the input and the output data, and so for that reason you also include the not seen studies. So the full data is the CSV that you have to provide, and this other technical data file, it's a file that you can only see with some codes like this, but I think that you only have to, because in ASReview you can export the project, and when you export the project, you export as .asreview, and then you only in the manuscript or in the article just state that you have provided the CSV file and the ASReview. And if some people want to check these specific details, that person just need to do some coding, maybe use Python and check specifically these kind of things. So to report in your study, and this is like a very detailed text, but I think that maybe you could consider to only state that you follow the stage procedure, or maybe and the RDAL checklist. And well, I think that all of these things can also be applied for the protocol, except with the exception of this text with gray, because but all the rest you can include in the protocol, because it's basically the item number 1 to item number 7. And thank you for watching this video.